In the United States, soil is classified as stable rock, A, B, and C. A is highly cohesive soil, which has not been previously disturbed and is not saturated. B soil may have been previously disturbed, but is cohesive and is not saturated. C is granular or saturated soil. If soil is granular, it probably contains a lot of sand and is unstable and likely to shift and move easily. If it's cohesive, it probably contains a lot of clay and the walls of an excavation will be more stable. Since pipeline maintenance work involves previously disturbed soil, it's usually type B soil. There are a number of lab and field tests that can be conducted to determine the type and stability of soil. For example, a plasticity test is conducted by taking a wet sample of soil and trying to roll it into a thin thread without it crumbling. Cohesive soil can be rolled into a thread successfully, and granular cannot. Another test is the dry strength test. If a dry soil sample crumbles on its own or with moderate pressure, it's granular. If it crumbles into smaller clumps that resist pressure, it's cohesive. A thumb penetration test can be conducted in the field with soil that has recently been excavated. This test will show that type A soils can be indented, but not easily penetrated with a thumb, while type C soils are easily penetrated and molded with light finger pressure. Once the project is underway, crew members should monitor changes in the soil's condition due to changing weather or work conditions. Moisture from a waterline leak or a rainstorm can quickly destabilize the walls of an excavation. Freezing temperatures or earth movement from traffic vibration or heavy equipment on the job can cause cracks in the walls, which can lead to cave-ins. If an excavation is deeper than 5 feet, some method of protecting workers in the excavation must be provided. Examples of excavation protective systems include sloping, shoring, or using a shield. Engineers and crew members will determine the appropriate sloping or angle of a trench or excavation. This ensures that the downward forces on the soil are never allowed to exceed the soil's cohesive strength. It's called the angle of repose, and if workers dig a trench at the proper angle, it won't slide or cave back into the trench. The angle varies with the type of soil, the amount of moisture in the soil, and the surrounding conditions. For example, type A soil requires a 3/4 to 1 ratio, 3/4 of a foot out from the edge of the ditch for each foot of excavation depth. Type B soil requires a minimum of a 1:1 ratio, or 45-degree slope. Sometimes, because of the instability of the soil, sloping isn't enough. Then it's necessary to consider shoring or shielding to protect the workers and the project itself. Shoring will prevent cave-ins by maintaining pressure against the trench walls with a framework support system of wood and/or metal. Uprights are vertically placed boards that are in direct contact with the trench walls. Stringers or whalers are horizontal support boards to which the braces are attached. Trench braces are either boards or adjustable trench jacks that run across the excavation to keep the uprights separated. Shoring and bracing should always be installed from the top down and then removed from the bottom up once the work is completed. Sheeting is sometimes used in conjunction with shoring by placing tightly spaced upright planks against each other to form a solid barrier against the trench walls. Shielding involves the use of a steel box that is open at the top, bottom, and ends. As the work progresses, the box is pushed or pulled along the trench to protect workers in the event a cave-in occurs. The shield should extend 18 inches above ground level. There are specific local and federal regulations that contain specific guidelines for sloping, shoring, and shielding.